So one of the basic components of electronics is about resistors. So from the word itself, resistor came from the root word resist. So their main function is to resist something. So what is a resistors? So it is an electronic component that limits current flow. So it resists the flow of current and produce a desired voltage drop. So there are many types of resistors. We have the Wirewound Resistors, the carbon composite resistor, the very most common resistors available in the market, and we have the precision type resistors. We have also the SMD type resistor. It's a very small resistor commonly found on your mobile phones, computers, and other small gadgets. We have the fuse resistors. So it's a resistors that act as a fuse. And also lastly, we have the thermal resistors. A wire wound resistor. So a wire wound resistor is a resistor where a wire with a high resistivity is wrapped around an insulating core to provide the resistance. They are usually very big. Carbon composite resistor. So it's the most common resistor available in our market. It is made of fine carbon and graphite mixed with a powdered insulating material. It is easily identified due to its color strip pattern. So precision resistors. We have the metal film and also the carbon film resistors. So they are a special type resistor because it is a resistor having a precise value. It has less tolerance and the values does not change during change in temperature or aging. SMD resistors. So they are called surface mount devices. Sometimes we call it as a chip resistor because it is like a chip, a microchip. It is commonly used in small electronics like mobile phones and motherboards of our computers. It is temperature stable and very rugged. Fuse resistor. It's a resistor that acts like a fuse, and it protects the circuitry when the power rating is exceeded. So it is easily identified because of its color strip. It's either black strips or sometimes it has a gold strips. It is made to easily cut open. Thermal resistors. They are temperature sensitive, meaning the increase in temperature will alter its values. They are called thermistors, the short term for thermal resistor. Thermistors. It is commonly found inside computers and projectors. So when the temperature increases, our projector will sometimes shut off. So its values changes as temperature change. It is to protect our system or other components from overheating. So resistor color codes. In this example, we have a 4-strip resistor. So the first digit is colored yellow. The second digit is colored violet. And the third digit is colored red. And the last strip, as you can notice that there is this space in between. So the largest space distance will make us identify that the last strip is our tolerance. So here are our resistor color coding. We have the black, the brown, the red, the orange, the yellow, green, blue, violet, gray, white, gold, silver, and none. So in our first band, our first strip, we have a value for black until white. So we start at 0 up to reach to 9. And to our second strip, we have also a value for our black until we reach to white. So for our multiplier, as you notice, we just multiply. The term is multiplier, so we just multiply them with the value of 1 if it's color black. For a brown, we just multiply the value we get. For example, we have brown, we just multiply 11 times 10. And so until we reach color white. So white has 9 zeros. As you notice, the first multiplier at color black, there has no 0. Meaning, the number here, this multiplier here, will denote the number of 0. If brown, we have 1 0, and to our white, we have 9 zeros. Okay? So for our tolerance, brown, red, and green, blue, violet, and gray are for our precision resistor. So our precision resistor. Precision resistor. And our very common tolerance color is our gold and silver. These are the common resistance. Okay. So for our first example, we have the color white, color blue, color red, and our tolerance is gold. So our color white, as you can see in our resistor color code, is designated as a value 9. And our color blue is designated as the digit number 6. So we have the first digit as number 9, our second digit number 6, and our multiplier, just multiply it times our color red, so which is 2. So we have times 100. So we have 2 zeros because our red is value 2, and in our multiplier it has 2 zeros. So we have a nominal value of our resistor of 9,600 ohms. Or simply we can write it as just 9.6 kilo ohms. Okay? So what about our tolerance? So we have here 9,000. So we just erase first this. So for our tolerance, we have 9,600. In our resistor color code, our gold signifies a 0.05 or 5% tolerance. So we have a 0.05. So if we convert 5% of 9,600, if we convert 5% to decimal, we just simply divide it by 100. So we have 0.05. Okay? So 9,600 times 0.05 is equal to 480. Okay? So we have 480. So to get the minimum value, we just subtract 9,600 by 480. So the minimum value is 9,600 minus 480. So we have 9,120 ohms. So this is our minimum value, 9,120 ohms or 9.12 kilo ohms. For our maximum value, we just add 480 to 9,600. So 9,600 plus 480. So we have 10,080 ohms. So minimum value and maximum value will signify that the resistor within the range of 9,120 to 10,080 is still in good condition. So this resistor with a gold tolerance will have a value when it's either cold or in a room temperature or in a cold temperature or in a heated temperature will jump from the range of 9,120 to 10,080 ohms. So it's still in a good pristine condition of our resistors. So your first exercise, you have the first strip of brown, second strip of red, and the multiplier of a gray, and the tolerance of gold. So okay, so you can do this exercise. So your next exercise, we have the first strip of orange, second strip yellow, third strip black, and last strip is silver. Next. So third exercise, you have 33 kilo ohms. You need to find the color code of a 33 kilo ohms. Okay. Okay, next. So the last exercise that I'll give you is you have 3 color orange stripes and 1 gold stripes. Okay, next. For a challenging question, you need to write the color combination of the resistor having a maximum value of 25.2 kilo ohms and a minimum value of 22.8 kilo ohms. So you need to find the color combination given only the maximum and the minimum value of the resistors. So have fun doing math. So bonus question, what's this type of resistors? Okay. So you may wonder why this resistor has only one stripe. So they are called jumper resistor. So by manufacturing, our boards of our computers are done by machines. So machine will place components and solder the components. So since machine have no capability of placing jumper wires, so the manufacturers devise a jumper wire that looks like a resistor. It's for the machine compatibility. Okay. So we have another type of resistor we call the variable resistors. So as you can see, this type of resistor is found on your mixture or your amplifier. We call that the slide resistors. And we call this the bank resistor or resistor bank. Resistor bank is mainly used for testing components. So we have different types of variable resistors. So these are usually big resistor. This type of resistor is very common to our audio devices like speakers. And this type of resistors are found inside our components. Okay. So they are either the rheostat, so the big one is the rheostat, and the small one are called potentiometers. So rheostat. It has a high-powered application. So usually it is used to our electrical components, like for example in Casoreco, they are using rheostat. And rheostat is also used for our in our AVR with what AVR, the most expensive AVR, the Stavol brand AVR. So it has only two terminals. Although you can see in the picture, it has a three terminals, but only two terminals are used. Okay, we are only using two terminals. So the two terminal type of resistor only varies the current. So we have the potentiometers. So potentiometers are low powered application. It has three terminals, although this one has six terminals. So this is for the left side of our speaker, and the other one is for our right side of our speaker. So for stereo application. So it taps off the part of the voltage. So it's used commonly as our volume control. And if you use only two terminals of a potentiometer, it functions as a rheostat. So it's used for as our volume control. So as you notice, when a potentiometer age, you cannot adjust the volume anymore, or there are certain part of the volume that has no sound application. It means you need to replace the potentiometer, because the more you move the potentiometer, you are scratching the inside part, which if it's already old enough, it will not have any more contact. So if there's no contact, there would be no sound output. So the difference between rheostat and potentiometer. Okay, so we say that rheostat is high-powered application. It has two terminals. We only use two terminals for the rheostat, and it only varies current. But for a potentiometer, it is a low-powered application suitable for our audio systems. It has three terminals. We use the three terminals, and it taps off the part of the voltage. And it can be used as a rheostat